So now we talk about what's it called? We talk about angular momentum. So we want to do angle now, dimension of angles, angular momentum, angular momentum, momentum. So angular momentum, we can do it in two ways. Angular momentum, um, angular momentum is represented with L. L equals to I W. Okay, or we can say L equals to R times P. I'm still going to explain this to you. This why is L equals to R times P. So if it's R M V sine theta. Now there's something you have to know about dimension. It's very very important. I was waiting. I want to wait to tell you when we are doing homogeneity, but I need to tell you now. Any angle does not have dimension. Angle are dimensionless. When something is dimensionless, that means it is one. So you can say when something is dimensionless, the dimension is m raised to power 0, l raised to power 0, t raised to power 0. That means n raised to power 0 is 1. So this one can be represented as 1. So this is what it means that something is dimensionless. The dimension is what? 1. Anything that is dimensionless, the dimension is 1. So it does not mean that it does not have dimension. The dimension is what? M raised to power 0, l raised to power 0, t raised to power 0. So n raised to power 0 is what? 1. So what I want to point out there is, now, any angle does not have, all angle does not have dimension. Anything angle does not have dimension. You have to note that. Anything angle does not have dimension. Also, anything raised to power does not have dimension. You have to know that too. Like, imagine I said 3 raised to power 2 Newton. Does it make sense to you? Doesn't make sense. So anything raised to power, we'll still use it when we are doing homogeneity. So I want you to note it now. One, anything angle does not have dimension. Two, anything raised to power does not have dimension. You have to know that. So we'll still use it later. So I'm just telling you now. So in this case now, if you look at it, I said L equals to RMV sine theta. Because sine theta is an angle, it does not have dimension, so we can just rub this one off because it does not have dimension. So since sine theta does not have dimension, so we can now say that is equals to what? What's the R? R is length, M mass is big letter M, and V is what? L T minus 1. Okay, LT minus what? Minus 1. So L can be what? L is what? Is now, let's do it properly. Is now L square MT minus 1. Or you can say is what? M L square T minus 1. It's very important. So that's the dimension of what? Angular momentum. Or we can do it this way. 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 Inertia, we did inertia the last class, that way you can check it. Inertia, the dimension of the I is inertia. The dimension of inertia is inertia L. Inertia is what? Remember, is M L square. Abi times what's the dimension of angular velocity? You know, it's t minus 1. So L is still what? M L to t minus 1. So you can do it in two ways. T minus 1. You can do it two ways. So it can be either L equals to M VL sine theta. You still get ML to T minus 1. If you use this, L equals to IW2. I is inertia. Inertia is ML raised to power 2. W is T minus 1. So it's what? ML to T minus 1. So I don't know why minus 1 is not going there. So this I want you to note this now, which is very important. I want to know this. Now, this is just the code. Let me just give you one. I said the first rule is one, all angle are dimensionless. Dimensionless. Same as n raised to power. Any raised to power to power. Okay. And now the last one, let me rub this off for the last one so I can see. Last one is that all angular stuff is not the same as the linear stuff. For example, now angular distance equals to what? S over R. Angular velocity equals to what? W over R. Okay. Angular momentum